So, in the last class we have studied about axial line. Now we will study for equatorial line. So, what is equatorial line? So, consider this as a dipole. This is minus Q, this is plus Q. Now this is the midpoint O. This length is L, this length is L. Now draw a line perpendicular to the axial line and passing through the midpoint of the dipole. This plane is called equatorial plane. Any line in the equatorial plane is called equatorial line. This may be like this or any line in this plane. It's called equatorial line. So let P be a point on equatorial line at a distance r from the midpoint O of the dipole. Now join these two. This will be root over of r square plus l square. This is also root over of r square plus l square. If this angle is theta, this angle is also theta. So now what is equatorial line? It is the line perpendicular to axial line of the dipole and passing through its midpoint. Next, write down. Consider an electric dipole consisting of charges plus and minus Q separated at a distance L. So its dipole moment is P equal to Q into 2L from negative to positive charge. Let P be a point on the equatorial line of the dipole at a distance r from its midpoint O. Electric field due to the dipole at any point on equatorial line or broad side on position or tan B position. Equatorial point is also called broad side on position or tan B position. So now we have to find the electric field at the point P, which is at a distance r from the midpoint O. and it is placed on the equatorial plane. So let this point is A, this point is B. So we can say the electric field at point P due to charge plus Q. So plus Q charge पाई ए पॉइंट रे इलेक्ट्रिक फील्ड केते हबो E plus equal to 1 by 4 pi epsilon naught Q by R square. Now Q by distance is AP, it is equal to root over of R square plus L square. R square केते आसीबो R square plus L square. को डायरेक्शन रे हबो पॉजिटिव चार्ज पाई away from the charge, negative charge पाई towards the charge. So positive charge pi away from the charge. This is the direction of E plus. So we can write it as along AP. Similarly, the electric field at point P due to charge minus Q is E minus equal to 1 by 4 pi epsilon naught Q by square of this distance, but this is also root over of R square plus L square. Now its square will be R square plus L square, but this is the negative charge and electric field will be towards the charge. This is the direction of E minus. So you can write it is along PP. Now just consider the magnitudes, both have same value, so the resultant will be along the bisector of this angle. So this will be the net electric field E. Now if this angle is theta, this angle is theta, because they are alternate angles. Now this angle is theta, so this angle is theta. E plus and E minus have same magnitudes, but inclined at an angle 2 theta. So the angle between E plus and E minus is 2 theta. So the resultant electric field E at point P is along the bisector the magnitude of E is E equal to कौन होगा E plus square plus E minus square plus 2E plus E minus cos 2 theta. दीटा वेक्टर A और B थीटा एंगल रे इंक्लाइन हेतिले ताका रिजल्टेंट केते होतला रूट ओवर ऑफ A स्क्वायर प्लस B स्क्वायर प्लस 2AB cos थीटा. नाउ वेक्टर दीटा के अछंती E प्लस और E माइनस आउ ताका भितरे एंगल केते अछि 2 थीटा. सो केते हबो E plus square plus E minus square plus 2E plus E minus cos 2 theta. So E equal to, now E plus and E minus have same magnitudes. This will become E plus square plus E plus square plus 2E plus square cos 2 theta. that implies E equal to kete haba root over of E plus square plus E plus square 2E plus square plus 2E plus square cos 2 theta. 2E plus square common 1 plus cos 2 theta. 2E plus square into 1 plus cos 2 theta. 2 cos square theta. So it is 2E plus cos theta. Okay. That implies E equal to 2E plus 1 by 4 pi epsilon naught Q by R square plus L square into cos theta. Now consider the triangle POB. This angle is theta, this is 90 degree. So cos theta will be OB divided by PP. OB equal to L, PP equal to root over of R square plus L square. So it will be L by root over of R square plus L square. You can write this as R square plus L square to the power half. That implies E equal to 2 into Q into L. You can write it as Q into 2L, but Q into 2L equal to P. So it becomes 1 by 4 pi epsilon naught P by R square plus L square to the power 1 into R square plus L square to the power half. It will become R square plus L square to the power 3 by 2. And E is देखो dipole moment कहाँ पे है from negative to positive charge, but E is opposite to dipole moment because it is from positive to negative, and E is opposite to dipole moment P. So we can write in vector form as E equal to 1 by 4 pi epsilon naught minus P by R square plus L square to the power 3 by 2. Next, for a short dipole, L is very much less than R. So E equatorial is how much? 1 by 4 pi epsilon naught minus P by R cube. If you take the magnitude only, it will be E equatorial equal to 1 by 4 pi epsilon naught P by R cube, and the direction is opposite to dipole moment. So we can say electric field due to dipole is inversely proportional to R cube, and E axial by E equatorial equal to 1 by 4 pi epsilon naught 2P by R cube divided by 1 by 4 pi epsilon naught P by R cube. So E axial by equatorial is 2:1. Next, we'll go for electric potential due to dipole at any point on equatorial line. Electric potential due to the dipole at any point on equatorial line. Now consider the same dipole. We are finding the potential at the point P. So you can say the potential at P due to charge plus Q is V plus equal to 1 by 4 pi epsilon naught Q by R. The distance is AP, which is equal to root over of R square plus L square. Similarly, the potential at P due to charge minus Q is V minus equal to 1 by 4 pi epsilon naught minus Q by this distance. This distance is also root over of R square plus L square. The net potential at P is V equatorial equal to V plus V minus कहते हैं वो 1 by 4 pi epsilon naught Q by root over of R square plus L square plus V minus कहते हैं जी 1 by 4 pi epsilon naught minus Q by root over of R square plus L square. Now एटा जेतिकी एटा सेतिकी ये पॉजिटिव ये नेगेटिव आड हेले कहते हैं वो 0. So V equatorial equal to 0.